All right, so this week we're going to be looking in a little bit more detail at optimality theoretic grammars and how they deal with variation, in particular between languages, but also how they deal with deriving correct forms within languages. And so just to review from last time, this is a tableau. This is how we assess the predictions of some particular ranking of constraints for some particular word form in some particular language. And we saw there's some technical details about how to do this, right? So we have a bunch of constraints, right? These are in each column except the first. And those constraints can be interspersed between faithfulness and markedness. They can be in any order. It sort of depends on what you want the grammar to do. And then the constraints on the left are going to be construed as higher ranked than the ones on the right. So this is the highest ranked constraint, less high ranked, lowest ranked constraint. We list the inputs and the outputs in this column. So input up top. I usually include these slash symbols in order to make it clear that this is an input form, and then the output forms can have these square brackets, although they don't really need to. If you put them in the right place, it's clear which one's the input and which ones are the outputs. And right, so we're going to have the hypothesized input form over here, and this could be just about anything. We want our grammar to be able to deal with a wide variety of possible inputs because we think, again, that our phonological knowledge is an active system, a productive system that can be brought to bear on new forms. And then for each input, there are a number of possible outputs. In fact, there might be an extremely large number, but as we saw last time, we usually only need to look at a few relevant examples. And this example here that we're using to illustrate the system probably doesn't have enough possible outputs. We'd want to consider other things that you might do to this word sheep if you are a Maori speaker and it's phonotechnically illegal in your language. I've just given these three possible candidates here as a sort of illustration. In a real analysis, you might want to include other possibilities or things that might happen with this word, but this is just illustrating how the system works. And then for each constraint, for each candidate, that is for each cell in this table, we need to decide, does this output candidate violate this constraint? Right? And in order to do this for faithfulness constraints, we're going to need to look at each output candidate as it compares to the input. Right? So does this one change something? Does this one change something in here? Does this one change something in here? But for markedness constraints, like don't have a strident sound, we're only going to need to look at the outputs in order to figure out whether those are violated. That's the big difference between markedness and faithfulness constraints. If a constraint, if a candidate does violate the constraint in question, we put an asterisk in that box. And sometimes for clarity, if it's a constraint violation that eliminates a candidate from further consideration, we're going to use this exclamation mark to show that it's a so-called fatal violation. Oh, and I actually forgot to re-enter some of these constraint marks, so let's figure this out. Ident continuancy, we're just looking really at the initial consonant in here. This constraint says, hey, whatever the value is of the feature continuant in the input, don't change it in the output. So the sound esh, right, the post-alveolar voiceless fricative, is going to be plus continuant. And we just need to ask for each of these candidates, does it map it to something plus continuant? If so, then we're fine with this constraint. But if it doesn't, if it maps it to something minus continuant, then we're in trouble. So plus continuant, ha, plus continuant, ta, minus continuant. So this maps a plus continuant segment to a minus continuant one, violates this constraint, and because that's the highest ranked constraint in this hypothetical ranking, that's going to eliminate this one from consideration. Don't have a strident fricative is violated by the one that begins with a strident fricative, which is actually the faithful candidate in this case. That eliminates that from consideration. Changing the stridency is going to be anything that isn't the strident fricative here. So this one's okay, but these two are bad. And then finally, don't change the place of articulation, in particular coronal. Well, this is a coronal sound, this is a coronal sound, but ha is not a coronal sound, so we're going to give that a violation. And so this is how we assign marks. In the examples in here, sometimes I'll put a check mark in cells where the candidate does obey constraint, but you don't need to do that. Usually you just leave it blank, and that indicates there's no violation. Now, selecting a winner, or really often it's figuring out what the ranking predicts about what the output ought to be. For this, we're going to start with the highest rank constraint and ask, hey, do any of these candidates violate this constraint more than the minimum number of times? And the minimum is usually going to be 0. As long as there's some candidate that doesn't violate it at all, then the minimum is going to be 0. This candidate eliminates it, violates it more than 0 times, therefore it's eliminated. We don't even need to consider this one anymore, although we'll keep looking at it just for the sake of the illustration. So this is gone now. TP is not a possible output. Or it is possible, but it's been eliminated. And now repeat this for each lower rank constraint until you only have one candidate left. So in this case, for don't have a strident sound, one of these violates it once, one of them violates it 0 times. We're not considering TP anymore. And so yes, this candidate violates it more than the minimal number of times, therefore eliminate that one from further consideration. And now in this mini tableau, just for illustration, we've already eliminated this one, and that leaves only one candidate, which is heapy. And this is the actual output form that Maori speakers ended up producing with this English input, sheep, which is not a legal Maori word. So in this case, we just need to evaluate 2 constraints to find a winner. And this is going to be the output. So this is our prediction about what the grammar ought to produce. And so far, we've just been looking at this one word, sheep, but the idea is that the ranking of these constraints is about the way that a grammar or a language prioritizes different kinds of goals in the grammar, where the goals are things like don't change the input in various ways, or don't let this thing be pronounced for various things, right? And so this is just 4 constraints. There's going to be lots more constraints about all sorts of different features. But again, this is just for the sake of illustration. And the idea is that if this ranking gets us the right output for sheep, then it ought to work with other similar kinds of input forms. And there's going to be one tableau for each possible input form. And you want this ranking to predict the right results across a broad range of input forms that share properties. So for instance, if we were going to look at other cases of initial strident fricatives that occur before vowels, we would expect that Maori grammar, being a systematic, productive system of knowledge, is going to do something similar to other words like this. And if you look back to the handout where we talked about mappings, you'll find that that's true. So words like silk that also begin with a strident fricative also end up mapping that fricative to ha, right? Of course, in the word silk, there's going to be a bunch of other phonotactic problems that arise. Those are going to need other constraints and other candidates to be dealt with, but at least with respect to this particular property of having a strident fricative before a vowel, you're going to find that hopefully Maori consistently maps these in the same way, and so you would expect this kind of ranking to apply not just to the word sheep, but to any possible input form in Maori. That's the basic idea behind characterizing a grammar of an entire language in OT. So there's also going to be a question here about where do these constraints come from, right? Well, I mean, the sort of short answer for faithfulness constraints is that if there's a feature that's phonologically meaningful, then there's some faithfulness constraint protecting it. And more generally, any kind of phonologically meaningful change that you might make to an input form is going to come with some cost, right? Where the overall goal of the grammar here is to keep outputs relatively similar to their inputs. For markedness constraints in particular, though, this is going to be a little bit more complicated, and in fact, it's going to be really the subject of the next month or so of this class, is like where do we think these kinds of constraints come from in the first place? And there are two broad approaches to sort of figuring out markedness constraints. One of them is I'm going to refer to as the inductive approach. That means that we start with very specific patterns and try to infer things about the general pattern from those specific facts. And so in the case of figuring out markedness constraints, this is going to take the form of saying, well, let's look at how this phonological feature patterns in different languages, or in a specific language, or in a few specific languages, and then ask what kind of a constraint would you need to explain that, right? So even facts as simple as like Maori doesn't allow strident fricatives, and other languages do. Well, how are we going to explain that? Maybe one of these re-rankable constraints says don't have strident sounds, right? That's the kind of markedness constraint that would allow us to analyze this pattern. Therefore, maybe that's a constraint, right? So this is the case of inductive reasoning. We're going to do a bunch of that. There's another way of thinking about markedness constraints that's deductive, and this means that you start with very general principles and try to infer specific things from general principles. So what would the general principles be here? Well, most often these are going to be phonetic facts, right? So given how articulation works, or how acoustics works, or how speech perception works, what would a sensible markedness constraint look like? And we're not going to get to an example of that for a couple more lectures, but we're going to look at both kinds of constraint inference procedure here. We're going to start mostly with inductive reasoning, so looking around at some languages saying, hey, how does this feature pattern in different languages, and what kind of constraints would we need to describe that kind of patterning? In the next video, I'll talk a little bit about how we use these rankings to define different languages and think about variation between languages.